So proposition 31 says, through a given point, to draw a straight line parallel to any given straight line. This is pretty easy at this point. So here's the diagram. So we're given a straight line, that's BC. So proof, let a straight line BC be given. And a point A. And we want to construct through A a line parallel to BC. Okay, so I guess this is vacuous if A is on BC, so we assume otherwise. Now what Euclid says is let D be a random point on BC. As regular viewers of this channel know, that upsets me at least. But let's say it like this. I don't want to say random. I can't bring myself to say that, but let D be a point on BC. Now we know how to bisect a finite straight line, so I can just take it to be the midpoint, or the midpoint of a midpoint, or whatever, I don't care. Just pick a point on BC, which we can do. So D. Join A to D. Okay, now here's where we actually do something. So at the point A, on the line AD, let the angle DAE be constructed. Equal to the angle ADC. And this was, I guess, well, not last time, but recently. So this is proposition 23. So proposition 23 says that if you give me a line and an angle and a point on the line, I can construct on that line at that point a given angle. Okay, and I'm going to assume, what's the new letter here? DAE. Right, so E is over here. And that doesn't look so parallel, does it? Okay, let's try again. Guess I should do the smart thing and draw the line first. That's quasi-parallel. So there's E. So what proposition 23 allowed me to do was to construct this angle to be equal to the angle ADC, which is this angle. Now what it actually gives me, that proposition, is this part here, right? It gives me the angle, but then I can extend EA to this line. So how should I say that? Let F be constructed by extending AE. And that's postulate 1, I guess. At this point, we're not citing the postulates anymore. Okay, now I just have to prove that EF is parallel to BC. Since the straight line AD falls on the two straight lines EF, BC, making the alternate angles EAD and ADC equal, it follows from proposition 27 that EF is parallel to BC. as claimed. All right, so that's it for Proposition 31. Over to you, Kenneth.
Cool. I was going to make a comment here.
Yeah.
I think we're running into the issue of different sides of a line, right? Because this only works if E is constructed as the alternate angle to ADC, but if you constructed E where F is, then that doesn't work, right?
Yeah, that's a good point. Hadn't thought about that.
We've done like stuff like, okay, we want something on the other side of the line before, so maybe there's a statement about E being on the other side of ADC, right, or other side of AD, not the side where C is on, right?
I wonder if we can just read the proof of Proposition 23 and extract it from that. How did we do that? So we constructed, out of 3 straight lines, we constructed a triangle. Yeah, I think if we read back into Proposition 23, which relies on Proposition 22 to assemble the triangle, and the assembly of the triangle involves inscribing circles, and in that we do choose which side of a line to put the various things that we're constructing.
So it's kind of hidden. That truth is hidden.
Yeah, I think it's okay, but not from the statement of Proposition 23. I think you're correct. Like, we're doing this quite often, I think, actually, where we're actually invoking the construction in the proof, and the statement is kind of a summary, but it's not actually sufficient. This is one of the ways in which modern style is a bit more careful than Euclid, I think. Yeah, so this is a good point.
So like we pack more information in the statement rather than, having to rely on the exact construction of the proof.
Yeah.
Right. Yeah. This is like writing good object-oriented programming.
Yeah, exactly. Yeah, there's
you have to look inside it. You're not supposed to look inside it, right?
Yeah, exactly. Yeah, I guess it's maybe this style, I don't know the history, but maybe this style of trying to have the statements be a kind of API to the constructions is one of Euclid's contributions. Maybe before that, people were more inclined to just know a library of constructions and know what to do. I'm not sure, but that'd be interesting. Yeah.
Well, the other thing I was going to say is, did we have a construction where we dropped the perpendicular from a point to a line?
Yeah, that was 10 or 11, I think.
Yeah, if we did that, we wouldn't have to worry about choosing a random point on BC, right?
Yeah, that's what I was referring to. Yeah, so it's Proposition 9 that does that. Yeah.
Yeah, I guess if you do that, you won't even have to worry about which side of it you're on, right? You just right angles, just done.
Right. Sorry, it's Proposition 11. I just checked.
Cool.